Hello YouTube, my name is Satyendra, and in this video we are going to cover the reactive power, where does it come from, what its importance, the reactive power and the major blackouts, the reactive power delivery system, and how the reactive power is related with the dispatch system, and at last the advantages and disadvantages of the devices which produce the reactive power. Before we go further, let's try to understand what is the really reactive power and where does it come from. In a transmission line or in a circuit or in a network where the voltage and currents are not in phase, that means they are not synchronized, there are always the two components of the power, the real power, or we also known as active power, and it is measured in the terms of the watts. And basically this power is the usable power which can be used as the heat or any other form. The other component, the sign component or the imaginary component of the power, is known as the reactive power. It is also known as the imaginary power, and the unit is watts. V stands for voltage, A stands for the amperes, R stands for resistance. So the multiplication of these three quantities gives the unit of power, but in order to segregate the difference these two quantities, active and reactive power, we take the unit as the watts. Combination of these two quantities is known as the complex power or the apparent power. It's a vector product. If you find the complex power, then P is equals to vector I into the vector product of vector V. This will give you the complex power. So the now question is, why do we need at all the reactive power? We all know power generated from the generating station is transferred through the transmission line to the ultimate user. So usually the loads are of inductor loads. In case of underload, the voltage at the receiving end increases than the voltage at the transmission end. So this causes the problem. So the voltage is maintained through the reactive power transmission at the receiving end. Other than this, the loads like motor load and the other load require the reactive power to convert the flow of the electron into useful work. And even more, when there is not enough reactive power, the voltage sets down. That is the first case, which what I explained earlier, and it is not possible to push the power demand by the loads through the lines. So you need to supply the reactive power in this case. Here are the some important points why we need the reactive power. It balances the grid to prevent the voltage problems. Reactive power level have no effect on the voltage collapse. It has a strong effect on the system voltage. You can change the system voltage by injecting the reactive power. So a lot of things can be controlled with the help of the reactive power. Now let's have a look on the power triangle. You can find the magnitude of the complex power by the following formula: real power square plus reactive power square under root. The real power can be found by the complex power multiplying by the cos phi, where cos phi is the power factor, and you can find the value of the power factor, that is the cos phi, by simply the formula real power upon complex power. So if you look at the triangle, this is the complex power triangle, also known as the power triangle. I have listed some of the major events related to the reactive power and the blackout. So it's not that much importance, but just to realize the thing, how much it is important for the system not to collapse, and to show the significance and the importance of the reactive power for a power system. Now try to have a look on the limitations of the reactive power. There are the several limitations of the reactive power. Reactive power does not travel very far. You have to generate it at the point of the use at the point of the use, and usually it is necessary to close in the location where it is needed. The supplier source close to the location, it is the problem of the supplier again. Then the reactive power supply reactive power supply is very closely tied to the ability to deliver the real or the reactive power. This is a very important point. Now as we have understood what is the reactive power, how it is generated, and how to implement it, now it is the time to have a look how to implement the reactive power control device. To In order to regulate the control device, it is desired to the desired nominal value. It is we often inject the reactive power, the regulated voltage, at the location of the injection. There are some reactive power supply mechanism like shunt capacitors, synchronous condensers, synchronous generators, static work compensators. So these are the few methods, and uh, these are actually the major parts to solve this reactive power problem, to control this. These are among the several methods, several techniques to control the reactive power injected into the system. So here are some advantages and disadvantages of the reactive power. I am not going to read out them. You can have a look on these. It's quite evident here. So thanks for watching the video. I hope I did not make it that much bore. Don't forget to subscribe my channel. It means a lot.